Today in physics, we'll be talking about a problem that deals with acceleration down an incline. This is our problem. We have a car represented by this box, and it's going down a hill, and it goes from rest, which is to say, at the beginning it wasn't moving, to 30 meters per second, and the time it takes to do this, this takes over a period of 6 seconds. So during the acceleration, we have this object that's hanging from a string, and the object has a mass of 0.1 kilograms. And the acceleration of the car is such that the string remains perpendicular to the ceiling as drawn inside the box. So we're asked to find both the angle theta as well as the tension in the string, which we represent with the letter T. Start off by finding the angle theta. So in order to do that, we first need to figure out the acceleration which the car goes through, namely a. So we know that a acceleration is equal to delta v over delta t, where delta v is the differences in the final and initial velocities, and delta t is how long the change in velocity takes place. So we know that our final velocity is 30 meters per second. And since we minus the initial velocity, where we started from rest, which means that we weren't moving at all, so our initial velocity was 0 meters per second. And we're given that the time that it takes to accelerate from 0 meters per second to 30 meters per second is 6 seconds. So we find that our acceleration is 5 meters per second squared. So that's our acceleration. Now we can draw a free body diagram on this object that's hanging from the ceiling by the string and see what forces are at act to have such an acceleration. We're going to assume that there is no friction in this case, since we're not given any information about friction. So we have our object M with a mass of M, so this is the vertical, so this is our object M, and the string makes an angle of theta with the vertical. We know that there is the force of gravity acting upon it, namely m times g. But we want to decompose that into two components. One component will be perpendicular to the ceiling, namely this component, and the other component we want to split mg into is parallel to the slope, which is in the same direction as our A, namely this. So we can see that this angle is theta, so the component perpendicular to the plane surface is mg times cosine of theta, and the component that is parallel to the incline is mg times sine of theta, since mg is the hypotenuse here. So we find that the only force that will cause an acceleration downwards in the same direction as A comes from mg sine of theta. So the acceleration there is just this force, mg sine of theta, divided by m, so we get g times sine of theta. And this is going to equal to the acceleration which the car and the object go through, namely A. And we've calculated that already to be 5 meters per second squared. So we're going to use the value for g. G is equal to 9.8 meters per second squared. And right now we're trying to solve for theta. So we know that sine of theta is then 5 meters per second squared over g, which is just 5 over 9.8 meters per second squared. And this value is approximately a half, so we know that theta should be approximately equal to 30 degrees. And if we put it into our calculator, we find that theta does approximately equal 30.7 degrees. And so there is our first answer for the value of theta. Now that we've now that we've found theta, we want to find t, the tension in the string. And we can see that because this object does not fly off the ceiling, nor does it hit the ceiling, we assume that the string is rigid. So the tension T acts along the string, and the tension T must be equal in magnitude to mg cosine of theta, as it's pulling down, and since these two are balanced, the object of mass m will move neither down towards the ground or up towards the ceiling. So we have T is equal to mg cosine of theta. And now that we've calculated theta, we can plug in the numbers. So we have 0.1 kilograms times g, which we take to be 9.8 meters per second squared, times cosine of theta, which we calculated from earlier. And if we put this into our calculator, we find that T becomes approximately 0.843 newtons. And so there is our second answer. So we find that the angle theta, which the object makes with the vertical, is approximately 30.7 degrees, and the tension of the string is approximately 0.843 newtons.